All right, with this lesson, we're going to be doing Charles' law. And his law says that volume is directly proportional to the Kelvin temperature. So volume and temperature have a direct relationship only when pressure and the amount of the gas are constant. Okay, so if something's directly proportional, that means that when volume goes up, the temperature is going to go up. If volume goes down, the temperature goes down. So there's a direct relationship between the two of them. So we can write Charles' law two ways. You can either have the original volume divided by the original temperature equals the new volume divided by the new temperature, or you could have it cross multiplied and the original volume times the new temperature times the new volume times the original temperature. And that's your choice. You do not have to do both ways. You choose which equation is best for you. Now, in his law, he says it's only directly proportional when it's the Kelvin temperature. In the Kelvin scale, there's no negative signs. So you don't ever have to worry about having a negative volume or a negative, it's just negative volume. So you have to use the Kelvin temperature here. So remember, to convert from Kelvin to Celsius or Celsius to Kelvin, you have these two equations we learned back in chapter, I think it was 2 or 3. So if you want to go and you want the answer to be in Kelvin, you take the Celsius temperature plus 273. If you want the Celsius temperature, you take the Kelvin minus 273. So let's practice some problems. Oh, wait a minute, before we do that, let's look at these pictures. So you can see here, in this first picture, you have a small volume of space. In the second picture, you have a large volume of space. But in both of them, the pressure is the same. It's 1 atmosphere of pressure. So if you increase the volume, you increase the temperature. Okay, notice down here you have the flame. Increasing the temperature increases the volume of space. If you decrease the temperature, you decrease the volume of space. Since there's a direct relationship between them, when you would graph it out, you would get a straight line in the graph, just like we have over here, okay, showing that direct relationship. Okay, so now let's practice some problems. We have a gas at 89 degrees Celsius. Remember, it has to be in Kelvin, so we have to change that temperature. It occupies a volume of 0.67 liters. At what Celsius temperature will the volume increase to 1.12 liters? So we have temperature and volume, new temperature and volume. So the original temperature was 89 degrees Celsius, but that has to be in Kelvin, so we have to add 273 to that number, and it turns out to be 362 Kelvin. The volume at that temperature is 0.67 liters. The question is, at what Celsius temperature? So we don't know the new temperature. That's the thing we're looking for. If the volume increases, so our new volume is 1.12 liters. So Charles' law says that if the volume increases, okay, there's an increase in the volume, there's a direct relationship what the temperature will do. So if the volume's going up, that temperature should also go up. So let's plug it in. We'll use the V1 over T1 equals V2 over T2. You can use the other equation if you want, cross multiplied. We'll do that on the next problem. You can decide which one you like better. So the original volume was 0.67 liters. The original temperature in Kelvin is 362. You have to use the Kelvin temperature. The new volume, 1.12 liters. And the new temperature, we don't know. You have to cross multiply. So you're going to cross multiply solve for x, and you're going to find out that, which pen am I using? That you get, hold on, 362 times 1.12 divided by 0.67 is 605 Kelvin. Now the problem said what was the temperature in degrees Celsius. So remember that in order to go from Kelvin to Celsius, you have to subtract 273 from that value. So 605 minus 273, and we get 332. We only need 2 sig figs though because of this 0.67 over here. So 330 degrees Celsius. It's up to you whether you want to change the temperature to Celsius or keep it in Kelvin. This particular problem told you to change it to Celsius, so we had to. If it doesn't say to, then I wouldn't worry about changing it back. All right, let's try this problem. It says the Celsius temperature of a 3-liter sample of gas is lowered from 80 to 30 degrees Celsius. What will be the resulting volume of this gas? So let's write down what we know. So our original volume, right up here, is 3 liters. The original temperature was 80 degrees Celsius. Remember, we got to change that to Kelvin, so we got to add 273 to that number, and that's 353 Kelvin. The new volume, that's the question. What will be the volume? So we don't know. And the new temperature, you went from 80 to 30. So 30. Change that to Kelvin, and that is 303. This time, let's use the cross-multiplied equation. So we have V1 T2 equals V2 T1. So this one's been cross-multiplied. If you like this one better, that's great. Plug in what you know. Just watch your T's. The 1s and 2s are on opposite sides. So just watch where the numbers are at. So the original volume is 3. The new temperature is 303 because it's T2 we're looking for here. V2 is our X, and T1 is 353 Kelvin. So we plug our numbers in. First of all, we're having a decrease in temperature. We went from 80 to 30. Chuck's law says there's a direct relationship between the two of them. So if you have a decrease in temperature, we should have a decrease in our volume. So plug this into your calculator, solve for X, and you should figure out that X is, how many sig figs do we need? We're going to need 3 of them, is 2.58 liters. And we'll do one more. This one, what is the volume of the air in a balloon that occupies 0.620 liters at 25 degrees Celsius if the temperature is lowered to 0? So what is the volume of the air in the balloon that occupies 0.620? So the original volume, 0.620 liters. The temperature, whoops, T1, that's T1, is 25 degrees Celsius. Change to Kelvins is 298. The question is, what's going to be the volume at the new temperature? So our V2, again, we don't know. And our T2 is 0, which is 273. All right, so choose which equation you like better. The fraction one, the cross-multiplied one. I'm going to use V1 over T1. equals V2 over T2. I'm going to plug my numbers in. 0.620 liters over my volume. Make sure you always put the Kelvin temperature in, never the Celsius temperature. You'll get the wrong answer. We don't know the new volume, and 273 is the new temperature. So you cross multiply, solve for that x, and you determine that x, and we only need 2 sig figs, because this number, wait a minute, 2 sig figs, let's see. We're going to need 3 sig figs here. So our answer is going to be, hold on a second, 0.620 times 273 divided by 298 is 0.568 liters. Watch your units. Volumes should be measured in liters here. Temperatures have to be measured in kelvins. Watch your units, and the big thing for Charles' law is it's a direct relationship, and that temperature has to be in Kelvin when you plug it into the equation.